What if you could build and deploy a complete ERC20 token on Arbitrum with a working front end in under 7 minutes? I built a Claude code skill that does exactly that. Let me show you how it works. I'm opening Claude code inside an empty project directory. The first thing I do is load the Arbitrum dApp skill. If you're not familiar with Claude code skills, they're a way to give Claude a deep specialized knowledge about a particular domain. In this case, the skill contains 6 detailed reference guides covering everything from Stylus Rust SDK patterns to Foundry deployment scripts. I give it a simple prompt. Let's build a simple ERC20 contract and test it on a local dev node. 1 sentence, no boilerplate, no config files, no specifying which tools to use. Claude starts by checking what's already in the project directory, then scaffolds a new Foundry project with Forge init. It knows to use Forge init and Foundry because the skill solidity reference guide specifies it as a standard toolchain for Arbitrum development. Foundry gives us fast compilation, built-in testing, and a scripting system for deployments. Now Claude writes the actual ERC20 contract. Watch how it handles this. It doesn't just generate a minimal token. It writes a proper implementation with a constructor that takes a name, symbol, and initial supply. It includes the standard transfer approve and transfer from functions along with a balance of and allowance mappings. This follows the patterns documented in the skill's solidity reference, which also covers Arbitrum specific considerations, like the 2-component fee model, where you pay for both L2 execution and L1 call data. It removes the default counter contracts that ship with Foundry, which is a nice touch, and then it runs Forge build. The compilation succeeds on the first try, no errors, no missing imports, no version conflicts. Claude isn't guessing at the right solidity version or import paths. It knows the exact configuration that works. Now, next comes up the local development environment. Claude clones the Nitro devnode repository, which is Arbitrum's official Docker-based local chain. This is a full Arbitrum node running locally, not just a generic EVM chain that doesn't know Arbitrum well. It has the same precompiles, the same gas model, and the same L1, L2 message passing that you get on Arbitrum 1 or Sepolia. The skill knows the pre-funded deployer account, the RPC endpoints on port 8547 and 8548, and even the chain ID, which is 412346. Now, once the dev node will be running in just a moment, Claude will start deploying the contract. And you could see the deployment transaction which will go through. The effective gas price, the deployer address, the gas used, and most importantly, the deployed contract address. All of this will be happening on a local Arbitrum chain that behaves identically to production. The skills deployment guide covers both Solidity deployment with Forge scripts and Stylus deployment with Cargo Stylus, including contract verification on RBScan. Now, here's where it gets interesting. Claude doesn't just deploy and stop, it actually tests the contract on-chain, as you see right now, by running a token transfer using Cast, Foundry's command line tool for interacting with smart contracts. It sends tokens to a test recipient address, then checks the balance to verify everything worked. Look at that output. The recipient has tokens. The deployer still holds their original balance, minus those tokens it transferred. The transfer event was emitted in the transaction logs, which you can verify on-chain. The contract works exactly as expected. This kind of end-to-end verification is something the skill encourages. Its testing reference covers those unit tests, fuzz testing, integration tests, and even fork testing against live testnet state. Now I ask Claude to build a simple front end to interact with the contract. This is where the skill's front-end integration guide kicks in. It specifies viem for core chain interaction and wagme for React hooks, which is a modern type-safe approach recommended by the skill. Viem gives you full type inference from contract APIs, which means your IDE catches errors before they hit the chain. Claude sets up a Next.js app and installs the key dependencies, viem, wagme, and hand-stacked React query, which WAGMI uses under the hood for caching and state management. The skills front-end guide includes the exact chain configuration for the local dev node, Arbitrum Sepolia and Arbitrum 1. So Claude knows how to set up the WAGMI config with the right RPC URLs and chain IDs for each environment. Now, this is the part that really shows the power of having a specialized skill. Claude writes 3 components. First, as you're going to see in just a moment, a connect wallet component that uses WAGMI's useConnect and use account hooks with injected wallet support for MetaMask. Then a token info component that uses useRead contract to pull the token name, symbol, total supply, and the connected wallet's balance directly from the contract. And finally, a transfer from component that uses useWrite contract to send tokens with a transaction confirmation handling. Notice how it now structures the page once it's done with all the components. The main component uses all 3 subcomponents together, with the token info and transfer form only rendering when a wallet is connected. It's using the typed ABI pattern that the skill recommends, where you import the contract ABI as a const and get full TypeScript type inference in every contract call. No manual type definitions, no any casts. If you change the contract, the types update automatically. And now here's the summary of what Claude built: a complete front end with wallet confirmation connection, token info display reading on-chain state, and a transfer form that writes transactions. It provides everything one needs for the local dev node: network name, RPC URL, chain ID, and ETH as the currency symbol. It also gives you the deployer's private key to import into MetaMask or any other browser wallet so you can interact with the token balance. What you just saw was a complete Arbitrum dApp built from a simple and single natural language prompt. Let's see it in action. And here's the dApp running in the browser. You can see the connected wallet address in the top right. The token info card is pulling data directly from the contract with all the information one needs. Below that, our wallet balance shows 500 tokens. The transfer card has fields for recipient address and an amount, and everything you need to talk directly to the contract's transfer function. We'll enter a recipient address and we're going to send 50 tokens. When we hit the transfer button, WAGMI handles the full transaction lifecycle, and it'll prompt our browser wallet for confirmation, submit the transaction local dev node, and wait for the receipt. And in just a moment, you're going to see it. The transfer will be confirmed with the full transaction hash displayed, a complete working Arbitrum dApp from contract to front end, all built with a simple cloud code session. The Arbitrum dApp scale is open source and you can install it right now. Just run the one-line install command from your terminal. Once it's loaded, you can build Solidity or Stylus Rust contracts, deploy to local dev nodes or production, and scaffold full stack dApps with React front ends, all with the same single prompt workflow you just saw. Link in the description.